This session is about solving simple trigonometric equations. Grade E students will be able to find one solution of an equation of the form sine or cos or tan x equals k, where k is a constant. Grade C students will be able to find all the solutions within a given range, and Grade A students will be able to use their ability to solve trig equations to tackle unfamiliar problems. Section 5. Simple trigonometric equations. Page 12 of the C2 booklet. Now the first graph here is the graph of y equals sine x. The second graph is the graph of y equals cos x. The third graph is the graph of y equals tan x. And what we're going to do is we're going to split each of those graphs into 4 quadrants. And we're going to correspond this to what's called a cast diagram. So in a cast diagram, that's 0 degrees, that's 90, that's 180, that's 270, and it goes all the way around to 360 degrees. Now in the 0 to 9 quadrant, sine is above the x-axis, so it's a positive function at that point in that quadrant, as is cos, completely above, as is tan, completely above. So in the cast diagram we label the 0 to 90 quadrant as A, which stands for all, because all functions are positive in that quadrant. In the second quadrant, 90 to 180 degrees, sine is positive because it's still above the x-axis, but cos and tan are negative because they are below. So we denote the 90 to 180 quadrant with S, standing for sine, as sine is the only function that's positive in that quadrant. In the 180 to 270 quadrant, sine is negative, cos is negative, and tan is positive. So similarly we label the 180 to 270 quadrant as T for tan, as tan is the only positive function in that quadrant. And for the final quadrant, 270 to 360, sine is negative, cos is positive, and tan is negative. So C for cos is the only function that's positive in that quadrant. And we call this diagram the cast diagram, as we have C, A, S, and T. So in this case we're trying to solve sine theta equals a half, where theta is between 0 and 360 degrees. So we start off by doing sine inverse of a half, which we can do on a calculator or through our exact trig knowledge to find that theta must therefore be 30 degrees. Now that is only one of the solutions in the 0 to 360 degree range. Now going back to the curve, if we drew a line across from a half, we would actually find we expect 2 solutions. And in fact, sketching a trig graph is one way of solving this, but in that case you would have to learn the shape of all 3 trig functions and remember which one is which at all times. However, the cast diagram can allow us to find the second solution by just remembering one diagram. So we draw the cast diagram, we have 30 degrees, so it's in the 0 to 90 quadrant. We don't need to draw it precisely, just a simple sketch will suffice. In this case we're working with sine, and it's equal to something positive. So sine is positive in the A quadrant and in the S quadrant. And because of the symmetries of the trig graphs, this is replicated in symmetries within the cast diagram. So the angle is always the same from the horizontal axis. Now we want to know the angle from 0 degrees, so we want to find the shaded angle. So angle straight line add up to 180 minus the 30. The second angle is 150 degrees. Example 2, cos x equals root 3 over 2. We start off in a similar way, but this time it's cos inverse that we need to do. Cos to the minus 1, root 3 over 2. Sticking it into the calculator, or remembering from our knowledge of exact trig ratios, first angle we get is 30 degrees. We put in our cast diagram. In this case, working with cos, and it's equal to a positive value, so our other quadrant is the C quadrant. Again, the angle is the same from the horizontal. So to find our second angle, 360 degrees is a complete turn, minus 30 degrees, because the angle we actually want is all the way round from 0. The shaded angle. So the second angle required is 330 degrees. Example 3, tan theta equals 0.776. Now this won't lead to as nice angles as we had in the previous examples. We start the same way, tan inverse of 0.776. And our calculator gives us 37.8 degrees to one decimal place, which we again sketch in our cast diagram. Now this time working with tan, again, it's equal to something positive, so the other answer will be in the T quadrant. The angle from the horizontal will be the same, but we need the angle from 0, so we need to add 180 to 37.8. We get 217.8 degrees. However, the region we're working within is minus 180 to 180. So the solutions we've got here are from 0 to 360 degrees. Now the 37.8 is in the correct region, but the 217.8 isn't. Now to get it into the correct region, we can, if we add 360 degrees or subtract 360 degrees, that's a complete revolution, so it's an equivalent angle. Now in this case we need to go backwards, so we do 217.8 minus 360. So we get minus 142.2 degrees to one decimal place, which gives us our two answers in the correct required region. Example 4, sin x equals minus root 3 over 2. So again, sin inverse minus root 3 over 2. And our calculator gives us minus 60 degrees, which is not in the region that we've been asked for. However, we start at 0 on our task diagram and we end up at 90 if we go anti-clockwise. If we go clockwise, we're going in the opposite direction, so we would get minus 90. So the 60 degrees here would end up in the C quadrant. And the minus is just telling us which direction it's going in. Now in this case we've got sine and it's equal to a negative value, minus root 3 over 2. So the solutions we'll get will be in the quadrants in which sine is negative. The one the calculator gave us was in C, the other one we need is in T. Again, we get our symmetries from the horizontal. In this case we'll need to work out both angles from 0. So the first one is 180 plus 60, which is 240. And the second one we'll get by doing 360 minus 60, which gives us 300 degrees. Minus 60 is technically not a solution as it's not between 0 and 360 degrees. Solving trigonometric equations is particularly useful in science, especially mechanics within physics and engineering.